Alright, Chapter 7, Sleepers. Sleepers are transverse ties that are laid with the support on the rail. They have an important role with the track. They transmit the wheel load from the rail to the valve. Several types of sleepers use the rail. The characteristics of the sleepers are suitable with the respective load conditions that are described in this chapter. Section 1. Functions of the function and requirements of the sleeper. The main function of the sleepers are followed with the holding the rail in the correct gauge of alignment to give it the firm with enough support of the rail. Transfer the load evenly with the rail to wider area of the ballast. Act as an elastic medium between the rail and the ballast to absorb the blow of the vibration caused by the moving load. Provide longitudinal stability with a permanent wave. To provide the meaning for this rectifying the track geometry during the surface life within part with the performing these factors. Functions. Ideal sleepers should normally fulfill the following requirements. The initial wave that is also maintenance curve should be minimum. The weight of the sleeper should be moderate, so that the conventional handle the design of the sleeper. The fastening should be so that it is possible to fix and remove the rails easily. The sleeper should have sufficient bearing area so that the ballast under its non-cushion. The sleeper should be such that it's possible to maintain and adjust the gauge properly. Made into the material of the sleeper. The design should be such that it does not break the gauge get damaged during the packaging. The designer of the sleeper should be such that it's possible to have the track circuiting. The sleeper should be capable of resisting vibration shocks caused by the passage of the fastening and the move of the train. The sleeper should have the anti-sabotage, anti-theft feature. The sleeper density and sleeper spacing with sleeper. The sleeper density is normal to sleeper the per rail length is specified them n plus x or nx plus x, where n and m and x is the length of the rails, meter the x is the number that varies according to the factors such as the axle load and speed. B the type of the sector of the rails. C the type of the strength of the sleeper. The D the type of the ballast and the cushion. The E the nature of the formation. The sleeper measure the density of meters plus 7 the broad gauge route with the length of the rail with 13 millimeters means then 13 plus 7 the 20 sleepers used with the bird rail with the route or route. The number of the sleeper of the track can also specifically indicate the number of the sleepers per kilometer of the track. For example, the 1,540 sleepers kilometer. This specification prescribed relevant in particular in case of the sleeper rails are welded. The length of the rails does not have so much bearing on the number of the sleepers required. The system specifying the number of the sleepers per kilometer exists in many foreign countries is now being adopted by the Indian Railway as well. The spacing with the sleepers is fixed depending upon the sleeper's density. Space is not kept uniform with the trailing of and throughout the rail length with the close to the near of the joints. Cover the weakness of the joints and impact with the moving of the loads on them. There is, however, the limitation of the closing of the space with the sleeper is enough. The space is required for the working of the beaters. There are even the pack of the joints sleeper. The standard spacing of the specification adopted the fish blade and truck with the Indian Railways are given in the table 7.1. The notation to you the table explains 7.1. Spacing of the sleeper, the fish blade jointed sleepers, 380 with a wooden broad gauge between joint and sleeper. The first shoulder sleeper 610. Between the first sleeper shoulder, second shoulder sleepers density M4 640 630. Between the immediate sleepers D, the sleeper density M plus 4 and broad gauge center meeting 680 680. That's broad gauge. Now that a sleeper density with the indicator of the term the number of the sleeper requiring the space varying sleeper density is given in table 7.2. 7.1 shows the spacing of the sleeper's fish back track. The initial, intermediate, secondary shoulder, first shoulder, joint sleeper, fish, first shoulder sleeper, second shoulder, intermediate sleeper, joint and rail. Spacing of sleepers over the welded track. Number of the sleepers per kilometer 16,000, 1,660, 1,540, 1,310. Extreme center of the required speculation 602 millimeters, 649 millimeters, 763 millimeters. Lightweight track center of the field millimeters 600, 650. SW short weight track 680, 660, 670, 660, 680. Type of sleepers. The sleeper mostly used the Indian Railway are wooden sleepers, the cast iron sleepers, and the two steel sleepers, and the concrete sleepers. Table 7.3 compares the important characteristics of these. The service life, the weight of the sleeper of the broad gauge kilogram of handling, and 7.4, the wooden sleeper is the most ideal with the type of the sleeper that you believe is not intended to describe the passenger type of the wooden sleeper as follows the features. Specification: wooden sleeper should be economically provided with the described the strength of the sleep of the beam as well as the adequate bearing in the area. The depth of the sleep of the groove, the stiffness of the beam, and the length of the width of the control necessary of the bearing area. The bearing length of each of the real seat is 92 degrees, 92 centimeters, and 3 feet with the B broad gauge wooden sleeper, thereby giving an area of 2,325 centimeters square for the under each of the rail seat. With the size of the sleeper, there is broad meter gauge, and narrow gauge with varying area. The per sleeper are given in the table 7.4. Side of the wooden space for bearing areas. Broad gauge 275 times 25 times 13 is 0, and a bearing area per sleep with 0.465 meters millimeters squared. Meters squared. Meter gauge 180 times 20 times 11.5 0.3098 meters squared. Narrow gauge 150 times 18 times 11.5 0.209 meters squared. Bearing area per sleeper 2 meters squared. Alright, wooden sleepers required for the bridges and point for the crossing are thicker than section of 25 centimeters, 15 centimeters, or 25 centimeters by 18. The composite sleeper index, which involves the combination of properties, strength, and hardness, is an index used for the determination stability, particular chamber with the use of the sleeper with this point of the vehicle view mechanical structure. The CSI given with the form of the CSI is equal to S plus 10H over 20. With the S is the figure of the general strength of both green and dry timber to 12%. Mixture content H is the figure of the general hardness for both the green and dry timber with a 12% moisture content. The minimum of the SCI prescribed in the Indian Railways are following. Track sleeper, the minimum SCI is 783. Crossing sleeper are 1352. Bridge sleeper 1455. Bearing plates are invariable. Use the speed of the sleeper. The CSI value of the 82 or less. The SCI value, the value of the timber space is recommended with the Indian Railway. Making sleepers follow. Solid 112. Teak the 82. Dior 63. Sure 54. Wooden sleepers have the following main advantages and disadvantages. The advantages: cheap, easy to manufacture, absorb shock with the bearing, the good capacity with the dampening vibration, therefore retaining the packet well, easily handling without the damage, suitable for the track circuited section, suitable for the area of the yield formation. Alignment can be easily corrected, more suitable to modern methods for the maintenance that can be used without. Stone bells can be used for the bridges, asphalt ash pits also can be used for the gonulated track. Disadvantage: less life due to the wear, the decay attack with the vermin, liable mechanical wear due to the better beater packaging, difficulty maintaining the gauge, suspectability of the fire has negligible scrap value. As persistent wooden sleepers are being procured with the State Forest Department, the detailed instruction of the inspection for the sleeper is done at the time of the procurement of the ensure that the sleeper is accepted with a good quality, free of the defect. The main defects normally found in the sleepers are center heaves, the presence of the knots, warps, and wanes, the shake, the split end of the twisted cross grains. Normal surface life of the wooden sleeper in India is about 15 years, against with the much larger the strength of the surface life of the attained with the advanced railways, the weather, the condition, particularly of the rain, the humidity, are reasonable for the shorter lifespan. These sleepers in India committee with the employment with the railway board over the 1972 with examine this measure for the increase the surface life with improving utilization of wooden sleepers. Main recommendation of the committee is as follows: the sleepers should be procured with the nominated sleeper depots of the railways. The inspection sleepers should also be done railways in addition for the forest depot department. The net retention of the cruiser type fuel oil in the ratio 1:1 for the sleeper should be minimum 8 pounds per feet cubed. Bearing place the elastic fastenings are well. The modern method of maintenance should be measured with the shoveling package. Mechanical tampering should be progressively used with the wooden sleeper to avoid damage to the sleeper. To ensure longer life of the bearing plate should also be compulsory used with the traffic density exceeding 20 gross million tons through broad gauge routes and 5 million gross tons meter gauge routes as well. The joint sleepers on the curve with the radius of 1,500 meters sharp curves. The spike killed sleepers should be systematically reconditioned. Track depots should be organized in each raid to undertake the operation end biting and aging and the pre-boring of the sleepers. 7.4 durability, non-durable type of the sleeper. The wooden sleepers may be classified into the categories durable and non-durable. The durable sleepers do not require any treatment that can be laid directly on the track. The Indian Railway Board has classified their particular categories of sleeper as a durable type. The sleepers produced for the timbers such as Tikasal, Nora, Rosewood, Angin, Congo, Crumbo, Gam, Kong, Venji, Padak, Lakab, Mwanto, Mila, and Cruel. Alright, non-durable type. Non-durable type sleeper, the requirements before putting it on the track of the non-durable sleepers are made with the wood of the tree, such as sure, deodor, kill, and the conjun, and janima. I guess these are different names, like Indian names for them. And the non-durable type of the sleeper that put with the track directly without any preservative treatment of the sleeper will decay for a very short time. However, such as the sleeper is treated before after the very loss last longer. Their life is comparable to durable sleep. The first sleepers, however, they have been provided with a good service. They are used for the restrictions on those truck routes and the main line with the traffic density of not more than 10 gross tons per annual kilometer per animal. Primary surface life of the wooden sleepers is approximately as follows: durable 19 years, 31 years meter gauge; non-durable 12.5 broad gauge, 15.5 meter gauge. 742 treated and untreated sleepers. Wooden sleepers are also sometimes classified as hardwood, softwood sleepers, depending upon the original space of the wood with which they are made. With the broadly speaking, the timbers produced with the tree of the wood leaf known as the hardwood, obtained from the tree with the bearing long leaf that is considered softwood. Some of the hardwoods varieties that will require the treatment before being in the use in the track, as the recommendation of the committee. The use of the durable and non-durable as well. But the hard and soft should be done away from the wood. The use of the committee, the recommendation for the simplification rationalization, wooden sleepers should be classified in two categories. U for untreated with compromising all the sleepers made with the wood from natural durable species. T for the treated sleepers consisting of the rest of the sleeper. The treatment in sleepers. Indian Railway has set up the floor sleeper. The treatment plan for the locations given below with the treating of the non-durable sleeper. The Dillium Northern Railway, Nakat, Northern Frontier, Clutter, Bungajaga, Northeast Alcava, or Kerala, and Southern Railways. All these plants utilize pressure treatment as process with the preservative of the force in the wood under the pressure using any of the following three methods. Full cell or Bethel process. The Bethel process cylinder load will with the charge for about 300-400 sleep that first to drive the vacuum with the 55 to 60 centimeters of mercury with the 20-30 minutes by means of vacuum pumping. Hot crescent oil is then forced into the cylinder and pressure at 150 to 180 psi, the temperature of 180 degrees Fahrenheit. This pressure is maintained in the period for 50 to 70 minutes to the desired amount of the absorption is attained. Therefore, the pressure of the reduced cylinder is drained off the crescent oil. A final vacuum with 55 centimeters of the mercury is applied to the free with the timber, except for the preservative. The whole process takes about 2 to 3 hours. The process normally used with the maximum retention of the crescent oil required for the particular type of the sleeper, especially the medium, the calatar, DR, fur, etc. Present of the method of the Okavat, Clunnerbeck, and Dehan plants for the various types of woods. Alright, empty cell or root painting process. The root painting process of wooden sleeper loaded into the cylinder is first subjected with the initial air pressure of 3.5 to 5.25 kilograms centimeters squared for about 20 to 30 minutes. After, without reducing pressure from the hot crescent oil, force the cylinder at the temperature of 180 degrees Celsius or 210 degrees Celsius. The pressure is then raised to the value of 10.5 to 19.6 kilograms of centimeter squared. Avoid the period of 20 to 30 minutes within the desired absorption is achieved. Finally, the pressure is released. The cylinder is drained off with the corrosive tight, and the final vacuum is 55 centimeters of the mercury and is created with the drain off the excessive pressure preservatives. The whole process of the treatment takes 2 to 3 hours per charge. The process is generally employed with the treating prosperous timbers using the Dewan, Cutler, Bergbang, gauging, depot, sure sleepers, and process air cells entrapped thereby and limiting the preservative to be absorbed by the sleeper to a certain extent. Or your empty cell Lowry process. The Lowry process is a cylinder to loaded with the timber chamber that is filled with the subject to the pressure with 180 pounds without sufficient to ensure proper impregnation. The cylinder is then drained off with the timber subjected to the final vacuum of 55 centimeters of the mercury in the period of 45 minutes or so. The air is entrapped with the timber cell, forcing excessive permissive preservative out. The preservative recovery is greater than this case than a full cell process, but less than any rooting process. The process is used with the Nahracot plant and the very green species of timber. Alright, phothoathric treatment sleepers. Phothoathric treatment is given to the sleeper using patent chemicals such as arsenic, pentoxide, copper sulfate, the magnesium dichloramate solution in water 1 to 3 to 4, weight of 60% of the preventing infection of the frosthead. Within treatment plan with the necessary is necessary as an appreciable amount of the time elapsed in transferring the sleeper to the forest department depots in the treatment plant. Seasoning with sleepers. The wooden sleepers receive the reduced moisture contents of the treatment that is either effective with the Indian strainer scope, the practice of the preservation of the timber lows down with the moisture or content. In the case of the sleeper, the treated with the pressure of the treatment should not be more than 25%. The seasoning of the sleeper that can be done with any of the following process: the artificial seasoning of the kiln, the control method of sustaining seasoning timber normally used in the USA only in other advanced countries under the condition of the temperature, relatively humidity, which have range for the natural agent air seasoning, boiling under vacuum process which unsieve the wood is treated with the hot preservative to remove the moisture content. This is added to the nacarium de pepo. Air seasoning of this method is adopted extensively with the serious seasoning of the wood and the sleeper of the Indian. The sleeper is stacked with the timber yard with the provision, but they made enough circulation for the air in between the sleeper. The sleepers are stacked in any one way of the following ways: 1 and 9 method, closed crib method, and open crib method. Figure 7.2 throws the 1 and 9 method. Figure 7.3 shows the open crib method, and normally the 1 and 9 method is adopted by the Indian Railways for stacking the sleepers, but about 6 months is required to air season the timber fully with the method 743, lay with the wooden slayers. Sleepers, carefully care that should be taken to laying the wood sleepers. Untreated wooden sleepers should be laid with sapwood side upwards and the heart side wood downwards. So they ensure the minimum decay of the dew, the fungus is act on from below. More moisture would be also percolate with the sleepers lift laid out otherwise. In this case, treated sleepers, however, the heat or wood side is kept upwards with the sapwood side downwards. This is done by the becoming of the sap side. Sapwood side contains more creosote and is liable to less damage when from vermin and fungus. 744 anodizing wooden sleepers. In order to enable the rail to slightly tilt inward for the cam of 1 to 20, the wooden sleepers are required to cut this slope of the real seat before laying. This process of cutting the wooden sleeper to the slope of 1 to 20 is known as the anodizing of the wood sleeper. It may be pointed out with the anodizing cutting of the wooden sleeper to the slope of the 1 to 20 is done for the great care. Otherwise, the slope will vary with the sleeper resulting in the rough ride. The anodized surface of the wooden sleeper is treated with coal tar grease to tighten and ensure proper protection of the surface. Normalizing anodizing wooden sleeper is done only with the bearing plates are not provided. 75 steel channel sleeper. In view of the greater shortage of the wooden sleeper, the steel channel sleeper have been developed in Indian railways, particularly for the use of the only on girder bridges. The steel channel sleeper can be only used with a welded plate, with the riveted plates, as well as open welded web girded. Composite sleepers have been developed indigenous for the Indian replacement for the wooden sleeper. They are made with the waste products such as used rubber. The retirees of the manufacturer claim the lifespan of about 40 years for these sleepers. The paddle group of the industries is one such with the firm that developed these composite sleepers. The composite sleepers are similar to wooden sleepers that use a similar fitting to these. Sleepers are most under trial with the result so far of they have been quit encouraging. 7.6 Steel trough sleepers. About 27% of the track of the Indian rails are laid with a steel sleeper. The increasing shortage of the timber of the country, other economical factors are mainly responsible for the use of the steel sleepers in India. The steel sleepers have following a main advantage and disadvantage over wooden sleepers. All right, 7-4 shows the Stephen sleeper of the broad gauge of a 90R rail. Our advantage is long life, easy to maintain gauge length, less maintenance problem, good lateral rigidity, less damage during the handling, transportation, simple manufacturing process, very good scrape value, free of the decay, attacking the vermin, not susceptible to fire hazards, disadvantage, liable to corrode, unsuitable for track circuited areas, liable to become center bounded because of the slope of the two ends, develop with the crack on the rail seats during the service. The design is rail specific. Design features steel trough sleeper that essentially consists of the rolled steel plate with about 2 millimeters thickness, breadth, and suitable through the shape of the rail seat cannon to 1 in 20 of the end of the roll of the section, flattened out with the shape of the spade with the return of the spales. The two alternative types of the sleepers have been designed to each with the reaction of the rail section and part of the following details. So in one type of the lugs jaw with the head pressed over the plate with the itself with accommodate with the foot of the rail and the key of the several of the maintenance of the problem with these plastic plugs as they give the way to do the movement of the key as well to do the vibration impact of the moving loads in order to obviate the defect of another sleeper design has been adopted and designed to hold the punch into either side of the plate and accommodate the special design for the loose jaw of the rails are held up to help the student can keys driven in either of the into the press down up in the lugs onto its loose jaws. Alright, ST shows the sleeper with the pressed up lugs, pressed up lug key and ST sleeper. 7.6 shows the sleeper with the loose jaws inserted into the holes, loose jaws inserted into the holes, the keys, and ST sleeper. The adjusting of the gauge for the extent with the plus or minus 3 millimeters is done properly. Driving in the key, the double line section with the keys are driven in the direction of the traffic. Approximately weight the standard broad gauge through the trough sleeper is 81 kilograms. To the meter gauge sleeper is 35 kilograms. The steel trough sleeper has an average life of about 50 years and is accessible type of the sleeper for use with a long welded rail because of its lateral stability, adaptability for use with elastic fastenings. 762 classification. All steel sleepers conform to the Indian Railways specification T9 are classified with the first quality sleeper. The sleeper is not accepted in first quality but free from the following defects are determined as second quality steel for the trough sleepers. Inward tilt with the rail with the sight beyond the limit of the 1 inch through 1 in 15 or 1 in 25. Sleeper with a twist, the heavy scale fitting with a deep groove that causes a deep guide with the marks on the head of the blister, etc. First quality sleepers are normally marked in the green dot. Sleepers that have then been rejected. The first quality sleepers on account with the pipe with the seams, the lap, the bullet free with the defects indicated above the marks over the mark with a cross and yellow paint at the center of the all other second quality steel sleepers are marked distinctly with a 15 centimeter wide stripe with the yellow paint at one end. The sleeper through the sleeper that unifit the second quality given with a distinct red paint mark to avoid mixing with them with the first and second quality sleepers during the period. Loading. 763. The maintenance problems. If noticed that the keys used for the fixed rail of the steel sleeper tend to become loose due to the bending of the press filter of the lugs due to the wear of the rail seat, the holes of the gate elongated during the trip with a special type of the shims and liners that provided in this case the hole of the gauge long well. The motor single liner with a very effective type of liner with the holding the correct gauge of the oblong hole of the loose jaws. Another maintenance problem is the seal through the trough sleeper that is intended to become the current central bound with due to the care of not to be taken while packing. The ballast is normally removed at the center of the sleeper after the packing and ensure that the center binding of the sleeper does not take place. Sometimes the alignment of the steel sleeper tracks is also against effective with the overdriving of the keys. 7-7 cast iron sleeper. The cast iron sleeper is being extensively used by the Indian Railways. About 45% of the track persistence of the cast iron sleeper, and which may either be pot type or plate type. The main advantage disadvantage of the cast iron sleeper over the steel trough sleeper are as follows. Advantage: less corrosion and less probability of the cracking at the rail seat. Easy to manufacture, high scrap value. Disadvantage: gauge maintenance difficulty and tie bars gets bent, provides you less lateral stability, unsuitable with the track circuited lines, not variable, suitable with the mechanical maintenance of the MSP, but they come with the round bottom of the susceptible to the brake. Cast iron pot sleeper. The cast iron pot sleeper consists of the two hollow bowls puts on the circular pots of a circular elliptic shape placed in the inverted with the balloon ballast section. The two pots are connected by a tie bar which help the cotters to get in the grip. The cotters and gibs. The gauge can be adjusted slightly to plus or minus 3 millimeters or 1/8 of an inch to change their position. The rail is placed on the top of the pots, with the rail seated, provided with a cant with 1 to 1 within its help of the position, with the help of the key with the pot of the sleeper. The sharper the drawback of the cant be used on the curve sharper than 4 degrees on the broad gauge. Most of the plating is hidden with their inspection and maintenance is quite difficult. The sleepers have become obsolete now and are not produced in Indian Railways anymore. Are your cast iron pot sleepers show the dimension in millimeters? As your clip, your key, your gauge serve the grip, gib, and the tie bar. Your cast iron sleepers, CST9 sleeper, the standard sleeper that being most extensively used in Indian Railways is called the CTS or Standard Trial 9. Figure 7A becomes the 9th of the series produced for the central standard office. The sleeper is a combination of pot plate and boxer sleeper that consists of the two triangular inverted bots on either side of the rail seat. The center plate with a projected keel within the box. The top of the plate with the two CI a cast iron plate that connected with the tie bar with the help of the forecotter of the rail is held with the sleeper of the two-way keys provided each for the rail set with the side of the gauge face. The gauge is adjusted the value of 3 plus or minus 5 millimeters by alternating relative position of forecotters. Our details of the CSC S9 sleepers are 52 kilograms, rail gauge, RDSO drawing number, the weight, A, B, C, and D millimeters. This shows the CST9 sleeper of the cotters and keys and two-way keys, tie bar, keel, cotter, tie bar, key, rail. The rail seat with a CST sleeper of 150 millimeter wide, along with the length of the narrow bend, intended for the reduced rocking when sleeping on the about wave motion of the rail. The sleeper is designed to provide firm support of the rail, provide with a fairly good lateral longitudinal stability of the rail. The dimension of the CST sleeper and U for the I are given in Table 7.5. Sleeper provides a bearing area with approximately equally to the effective bearing area of the standard broad gauge wooden sleeper that is 5 square foot, both of the plates. The CTS plate 9 also available with the reverse jaw of the Type 443. Serve an anti-sabotage measure. The few of these provided with each for the rail length. Normally, the 3 reversible jaw CTS 9 sleeper provided per rail to serve the anti-sabotage purpose. The weight of the CTS 9 sleeper, the assembly along the passing of the broad gauge of 102 kilograms and meter gauge of 58 kilograms. The CTS sleeper is one of the most popular sleepers in Indian Railways at the present. The sleeper has, however, a certain limitation when confined within the monotrack as mentioned in the following. Sleeper does not have the flat bottom, is not quite suitable to the MSP with the mechanical maintenance with the high temperature suitable with the CTS sleeper with the low light welded reel. Particularly with the breathing of length, the doubtful to recover the rigid fastening and ability to fasten the hold of the rails with a constant tow load. The rail seat wears out quickly, recovering the keys to become loose. The sleeper has only limited longitudinal lateral strength to hold lightweight rails, particularly with the breathing length. Due to the even less metal under the rail seat, the shock vibrations are directly transmitted to ballast, resulting in poor retention or loose packing, and hence increased frequency and attention. The CTS sleeper and the meter gauge. A new design of the CTS sleeper has frequently recently developed in Indian Railways of the 90R rails on the meter gauge line shown in Figure 7.9. The CTS-10. The CTS-10 is an improvement of the design of the CTS-9 with a suit with the requirements of the monotrack. The basic design feature for the sleeper is the same with the CTS-9 sleeper except for the following improvements. The rail is held with the clip of the double coil springs washer instead of the fixed lug key with the insulation liners provided between the rail and the sleeper. A rubber pad is provided below the rail seat. The CTS and sleeper give it a certain amount of elasticity with the track and the virtue of the double coil spring washer with the sleeper that with the limitation that it cannot be used with elastic fastenings. CT11 sleeper. CTS11 sleepers are an improvement over the CTS standard sleeper. The special shoulder is provided to accommodate the Pandoral clip. Instead of clip the double coil spring with the elastic rubber pad is provided between the sleeper and the rail seat, instead of the rail resting directly on the sleeper. The CTS11 sleeper is potentially being used with the monotrack. The sleeper, however, the still experimental stage results are not very encouraging at present. The design details are shown in Figure 7.10. The CTS-12 sleepers are designed to suit the IRN 202 clip instead of the Pandoral clip. This in case the casting of the quite complicated due to the shape of the clip. No firm that is undertaken of the manufacture of the sleeper is yet. CST-13 sleeper. The CST-13 sleeper is using existing CTS-19 9 sleeper with certain additions alternation made with local warship that consists of the CTS-9 or CTS-9 sleeper with the gauge and meter gauge units. Your CTS-10 sleeper, the rail, rubber pad, Pandoral clip, cotter and tie bar. Plated rubber plate under the rail, additional rubber head to fill the gap of the occupied keep the rail fastened with the sleeper, the Sagma plug clip, similar to the fastening of the Swedish rail. To reduce the cost of the sleeper, the inner cotter is dispensed with a non-adjustable gauge and is possible. The sleeper, the CTS sleeper, is still under the trail. 7.8. Concrete tie. The need for the concrete sleeper has been felt mainly due to the economic consideration coupled with the changing of the traffic pattern. For the early days, the Indian Railway was only a materially used for making the sleepers in Europe. Even those days, the occasional short of the wooden sleeper there increased the price, posed the cost of the cause certain problems that gave the fill-up of the quest for the alternative material for the sleepers. Development of concrete technology with the 9th century's cosmetic concrete has established a place for style building material could be adopted as suitable to meet the requirements of the railway sleeper. In the year 1877, Mr. Monnier, a French gardener, the inventor of the reinforced concrete, suggested that the cement concrete could be used in making sleepers for the railway track. The Monnier in fact, designed the concrete sleeper to obtain the patent for it, but his design not worked successfully. The design was further developed by the railways of Australia. Italy produced the first concrete sleepers, promising design around the turn of the 19th century. This was closely followed by the European rails with the large-scale trials. The concrete sleepers were done mostly due to the economical consideration. However, not much progress could be achieved until the Second World War, which wooden sleepers particularly disappeared from the European market. Their price shot up almost at the same time. The result, extensive research carried out by the French railways and other European railways. Monotrack was born. Heavier rail section along welded rails came in an extension necessity for the heavier and better plate sleeper that could fit when the monotrack was felt. This condition gave the spur of the development of concrete sleeper. The continuous franchise Greater Britain went along with the developing concrete sleeper to perfection. Alright, it's raining out. I'm going to cut the tape because I don't want to lose the recording.